One of the main aims of this workshop is to move from the lab to the real world. We do not always have the information from the dedicated test using the speech recognizer. So we perform, in this case, for this experiment, trying to predict the UPDRS score of the patient. We use an articulation analysis with the energy content between the voice and non-voice transitions, with the red text, the monologues, and the repetitions of Pataca in Spanish, German, and Czech. We found relatively high correlation with the predicted value of the UPDRS score and the real value. For Spanish, we get 0.36, for German 0.22, and for Czech 0.45. And also, as was said previously, the UPDRS score is not always a good marker about the speech deficits of the patient because there are several outliers. So we try to predict the modified French A dysarthria assessment using the same information, the same features. The labelers, we have 3 different labelers that label the PCG dataset. They sit together and agree on the score for the first 10 patients, and then each one of the labelers for a patient and try to predict and label the information from the next recordings for a patient and 50 controls. And for the prediction, we use the monologue, the red text, and the repetition of Pataca. Those recordings was used by the labelers to label the data. In all of the cases, from all of the labelers and also from the median of the labelers, the best results was obtained with the rapid repetition of Pataca. We get 0.72 with the labeler 1, 0.62 with the labeler 2, 0.62 with the labeler 3. It's relatively high, having into account than the correlation, the inter-rater correlation among the labelers was 0.75. We highlight the same information for the predicted values for the labeler 1, the labeler 2, and the labeler 3. For the speech task, the repetition of Pataca. Now, trying to move from the lab to the real world, we performed several experiments across the different sessions of the longitudinal data. We performed the classification among the different sessions. For the first session, we have 50 patients and 50 healthy controls. For the second session, we have only 30 patients. From the third session, we have 19. For the 4, 16, and for the 5, 16. And we try to train a classifier with the first session and test in the other session using 12 different tasks, formed with 10 sentences, a red text, and a monologue, and take the final decision just with the unweighted sum of the prediction from all classifiers. This has the advantage that we can rank the patients and try with the aim of find the different outliers, such as the patient that was previously shown, which has a high UPDRS but a lower dysarthria level. And also one of the ladies from our control group, which was almost always misclassified, and it's just because she has no seats. So for this experiment, we train with the first session, the session 1 PD, session 1 HC. We get an accuracy around 80%, and test in the session 2, 3, 4, 5, and 6, and 5, and the at-home recordings, and also another data set formed with young, healthy control people. In summary, we perform the articulation, prosody, and intelligibility analysis. And in summary, in general, the highest results are obtained with the features from articulation based on this energy content of the voice and non-voice transition. But we are aware about that from session 2 to session 5 and also in at home, we get 100% of accuracy. And this is just because the acoustic condition of those sessions are very different to the recording in the session 1, especially for the healthy controls and As can be observed in this salmon map, the healthy controls from the session 1 are very different to the patients from the session 4, which obtained the 100%. So what we did is to, with the aim of compensate this acoustic condition, we add noise, white Gaussian noise to the session 1, to this, and train again and predict in the session 2, 3, 4, and 5, and the at home. And now we get, we think, more realistic results due to the similar acoustic conditions. But it's important to highlight that with the session 2, we still have highest accuracy, due to in some point that the acoustic conditions from the session 2 are the most closest to the session 1, as we get the same microphone and the same sound card. Now, for the experiments of cross-language, we train with the Spanish data and test in German and Czech. In blue, we can observe the accuracy in match conditions when the language for train and test is the same, and in red, the mismatch when we use different language for train and other one for test. Now the high reduction, especially in German, we go from 73 when we train and test in German, and to 51 when we train Spanish and test in German. Now, for the prediction of the UPDRS score across the different sessions, we use a supervector regressor with a linear kernel, a leave one speaker out cross-validation, and we perform an articulation, prosody, and intelligibility analysis to predict the UPDRS score in 12 different tasks, formed with the 10 sentences, the red text, and the monologue. Now for the articulation, we get different correlation across the different speech tasks. The highest correlation is obtained with the sentence 5, as here. We get 0.52 of correlation between the predicted values of the UPDRS score and the real values. This sentence is special because it's a complex sentence which has many pauses, doing that the patient have to start or stop the vibration of the vocal folds. And now the high reduction in the correlation when we train with session 1 and test with the session 2, this red stuff. And it's now for the prosody analysis, we sort the duration of the task according to their duration, from the shorter sentence to the monologue at the end. We can see a little trend about the between longer speech tasks, we get highest correlation. But again, as the UPDRS score is not a great marker to assess the speech deficits of the Parkinson patients, we try to predict the modified French dysarthria assessment using the same approach, then SBR with the linear kernel, the leave one speaker out, train with session 1 and test with others. We perform also the articulation analysis in 3 different speech tasks: the red text, the monologue, and the rapid repetition of Pataka. And we use the median between the leveler 1 and leveler 2 for the assessment. The articulation analysis, we obtain the highest result in all of the cases with the rapid repetition of Pataka, rather than with the red text and with the monologue. For all of the sessions, session 1 we get 0.67, session 2 0.58, session 3 0.63, session 4 0.72, and session 5 0.56. I highlight this one. In summary, the Pataka test which seems to be the most useful task to assess this articulation and to measure the speech deficits in the Parkinson patients. Now the combination. Julius will talk about combination with other modalities.